Hi there, and welcome back to Triplicate, home of interesting electronics. Today we're going to move on with the Arduino based alarm clock project using this multifunction shield board, and today we're going to try and get the display working. Okay, to do that first we need to understand how the display is connected up. Okay, as you can see, the display consists of 4 digits of 7 segments each, and along the bottom 4 decimal points. Now if we just connected up all those LEDs, that would be 4 8s, 32 connections, assuming each of the LEDs is common. This would make for a lot of connections to the micro, which quite frankly doesn't have that much I/O. So what actually happens is that each of the segments of each of the digits is connected together, and each of the digits is commoned, as you can see in the circuit. So to display a certain pattern, a number or something on a digit, you put that particular digit's anode side high and whatever segments you want to display low. And then for the next digit you put that digit's anode high and whatever segments you want to display low. This means that the whole display only has 12 pins, which makes it a lot easier to connect. Unfortunately, the downside of this is that you can only display one digit at a time. So then what you do is you display each digit in turn very quickly, and the human eye can only see things flashing up to about 15 Hz. So as long as you display each digit in turn at greater than 15 Hz, then you won't see it flicker. So what I propose to do is have a 100 Hz clock. So the whole display will be displayed at 25 Hz refresh rate, so we won't see it flickering. So to do that, we need to update at 100 Hz or 10 milliseconds. So I think that's probably the first thing we need to do. So what we're going to do is change our existing code so it updates on a 100 Hz refresh rate, and then we'll actually get into programming the display. Okay, so again I'm saving you the typing. Arduino gives you a function called millis, which returns the number of milliseconds since the program started, and as it says, it overflows after 50 days, so we're not going to worry about that. Okay, so what we've got is a tick time, which is the next 10 milliseconds tick occurs. Okay, so you see if millis, the millis time is less than the tick time, we don't do anything. If the millis time is greater or equal to the tick time, we set up the next tick time and we do what we need to do. So okay, the first thing we do is we read the switches. As before, I've got rid of the buzzer stuff because it was just confusing the issue. And we have the delay val again, which is the time between counts, which is now in units of 10 milliseconds, not 1 millisecond. So they're all a tenth the value. And we also have a delay count. This counts down every tick. And when it gets to 0, we reset the counter to the delay value, and we do our LEDs. And if the delay count isn't equal to 0, we just decrement it. Just a simple bit of code to test our new timer tick. And let's compile it and run it. Okay, and it seems to run nicely, so if we press that button, it goes slowly. I've made the slow a bit slower. And if we press that button, it goes quickly. Again, I made the quick a bit quicker. And if we press that button, it goes back to the normal speed. Okay, so now what we're going to do is every time we've been through here, we're going to call a function called display next digit, which will display the next digit on the display, on the multiplex display. Of course, if we try and compile that, it'll say it doesn't know it, it's never heard of it. So now we've got to get into writing that function, for which we need to go back and look at the circuit again to see how we actually drive the display. Okay, looking at the circuit for this multi-function shield, we find that the display is driven by two 74595 shift registers, there and there. This actually allows the display to be driven by only 3 I/O lines from the Arduino, but it does again make driving the display a little more complicated. How these shift registers work is that the data, the 8 bits of data are put to the input each in turn, and the clock value clocks them down the shift register. And there's an output at the end of the shift register going into the next shift register. So we need to organise, get our 16 bits organised, and then we clock them down, all 16. Yeah, we use what's called on here the LCH clock, the latch clock, which latches the data. And then we can shift some more data in, and that data will still be output. Okay, it's the next day, and I did a bit of typing last night. So I'll quickly go through what I put in, and then we'll see if we can get it going. Okay, so first things first, I created a new source file, display INO, for all the display functionality. It's good practice to have lots of small files, each file containing a specific piece of functionality. Also, I found out that Arduino, they don't use .c files and .h files like normal C code. They use these .ino files, and as you can see at the top, I've put these defines in. Well, those defines would be picked up by any.ini file instead of having to include them in a .h file. These defines are just the I/O pin numbers for the shift register. Below here I've defined a global array of 4 bytes which contains the 7 segment values for each digit. So if you look here, the first digit has 1 segment on, the second digit has 2 segments on, the third digit has 3 segments on, and the fourth digit has 2 segments on. They're all knots because to turn a segment on you put that output low. Okay, then we have a display init function which is called from the setup function. In fact, I'll call that display setup so it follows the Arduino naming, and that just sets those 3 pins that control the shift register, sets them to outputs and sets them to all low logic state. And this is the important one, display next digit. Okay, so it has a current digit which should be 0, and each time it's called it outputs the current digit and adds 1 to the current digit and ANDs it with 3, so the current digit goes 0, 1, 2, 3, 0, 1, 2, 3. Okay, and I've generated 2 variables, shiftReg1 and shiftReg2. shiftReg1 sets the anode line for the digit we're writing to, and shiftReg2 just sets the segment val for the current digit. Okay, so the first thing I do is make sure the clock pin's low. Then I call Arduino's ShiftOut function, which is conveniently provided to do all the shifting for you. So that wants a data pin, the pin that the serial data goes out, and a clock pin, an I/O pin number the clock's on, a bit order. Here we're shifting from the least significant bit to the most significant bit, and a value, the 8-bit value we're shifting out. And I'm using that because we're trying to use the Arduino built-in functions as much as possible, and if it works, why reinvent the wheel? Okay, so we just shift the first byte out, which is selects the digit we want to output to, and then we shift the second byte out, which is the 7 segment value. And then down here we simply put the latch pin high, and I put it high twice. I don't know how long it needs to be high. I could put that back to 1 if that works. And then we put the latch pin low, and we're done. And that should go round and round and round and right to the display. Okay, so as I say, it compiles. I know it compiles, but I haven't actually tried it. Okay, so shall we see if this works? Displaying it. That is because right, I'm going to call this setup display. I changed the name of the function while I was talking about it. So of course now it doesn't compile. Okay, try again. Looking good. Okay, something's happening, but not what we wanted. Okay, so I'm going to turn you all off and have a bit of a think about that. See what we've done wrong. Okay, so what's going wrong here? So after a bit of fiddling around, what I did was I set the shift reg values to these two fixed values and commented out the bits where they're assigned normally, and I looked again at the circuit for this display and thought, hang on, we're shifting that way, so we need to put the segment value in first, so that's shifted down into there, and then the digit value is shifted into this shift register. So I go here and change that to 2 and that to 1, so they're going in the other way, and I played around with that and I found these two values in here produce this result. Okay, so that is digit 1, the first digit, or digit 0, that's lit up, and yes, two segments are lit, but they're the wrong segment. So hang on, our next thought is, we are, as I said, going this way, so surely we need to shift the most significant bit in first. So let us also change that to most significant bit and that to most significant bit, and try again. Oh no, hang on, I need to put that to 1, which is the value we would expect to get the first digit to turn on. So we'll try again. So that's exactly what we expect. So let us go back. Well, for a start, let us call that shift reg dig and that shift reg seg, so we know what they're actually doing rather than giving them a misleading number. We'll put these back in. So that's dig, that's seg, so that's seg, and that's dig, and that should work. Let's see. Okay. Yep, that produces 4 separate digits, but there's rather a lot of flicker there, so we might look into that. Or possibly we might, for now, just try and display some proper digits. more satisfying. Okay, so I'll go away and do that and bring you back. Okay, so it's another day, and last night I decided to crack on a bit, and what I decided to do was just make the display count up at the same rate as the LEDs count, at which point we can say yes, the display works, and we can get in amongst writing the proper code for the application. So let's go through what I did. For a start, I doubled the speed it refreshed the digits, so now it writes and it shows the next digit every 5 milliseconds, which seems to remove most of the flicker. You can still see it flickering a bit if you stare at it very hard. And down here I've defined a variable, a string variable called dispstring, and down here I have written the counter value to it and passed it as a parameter to a function called displayString, which is in display.ino, and there we are, displayString. It just takes each digit of the string and converts it to its 7 segment value with the 7seg char convert function and puts it into the segval array, which the display next digit function picks up when it displays the digits. And the 7seg char convert function is very crude, it's just a switch statement, as you can see, case 2 for instance. So if the character is digit 2, number 2, it lights segments A, B, D, E and G, and it does those for all. Okay, so shall we compile and run this? Error updating checkboard is currently available. Okay. That's not helpful. I shall try unplugging the board and replugging it. Aha, that's worked. Okay, try again. And it works. And if I press that button, it'll go faster. Okay, well I think that just about wraps it up for this video. So next time we'll get on to actually starting on our alarm clock application. But for now, any comments, please leave them. Please subscribe to the channel. And it's goodbye from Triplicate, home of interesting electronics. Goodbye.